Okay, I'd now like to look at a couple of examples where we're combining transformations, but we're not looking at any specific function. We're just applying transformations to some general function y equals f of x. So we'll start with part A. We're going from y equals f of x to y equals 3f of x plus 1. In this question, we have two perpendicular transformations. The plus 1 is telling us to translate in the x direction, and the 3 is telling us to stretch in the y direction. That tells us that the order we do the transformations in will not affect the result. So let's start by applying the transformation. If we replace x by x plus 1, that's a translation of 1 unit in the negative x direction. So here we can replace f of x by f of x plus 1. The 3 is telling us to stretch by scale factor 3 in the y direction. Let's just check by applying it. So here we should be replacing y by y divided by 3. And then multiplying it by 3 gives us y equals 3 multiplied by f of x plus 1. So when we apply transformations in perpendicular directions, we generally won't come across any surprises. Let's have a look at part B. In part B, here, we have a translation in the x direction and a stretch in the x direction. As they're both in the same direction, the order will affect the result. So in this question, we'll actually have two possibilities to how we can derive the result. Let's start with the translation. We've got minus 8 here, so it makes sense to translate it 8 units in the positive x direction. Let's write down the effect of that transformation. That means we'll replace x by x minus 8. Then we'll apply the stretch in the x direction. For this one, as we're multiplying by 2, that's like dividing by a half, so the scale factor is 1/2. To apply this transformation, we replace x by x divided by a half, which is the same as multiplying by 2. And if we apply the transformations in that order, again, nothing out of the ordinary happens. However, if we apply the transformations in a different order, you might get a result you don't expect. Suppose we first applied the stretch of scale factor 1/2. At this point, things still seem quite straightforward. We just get y equals f of 2x. However, you have to be really careful with this next step. So, you might initially think, because we've got a minus 8 up here, it would make sense to translate it by 8, 0. Let's have a look at the effect of applying that transformation. We've currently got y equals f of 2x, and we're going to replace x by x minus 8. However, the key thing is here, if you have got something attached to the x term, in this case a 2, when you replace x, the 2 is attached to whatever you replace it with. So here the 2 would be attached to the x minus 8. And as we can see, if we expand out these brackets, we're going to get f of 2x minus 16, which is not what we want. However, all is not lost, because by making this mistake and by writing out the working out, it becomes relatively straightforward to see how to correct our answer. The minus 16 is twice as large as we wanted because we ended up multiplying it by 2. So to correct that, we can simply replace this 8 by something half as big. So if we pop a 4 in here and translate by 4, 0, that would mean we'd be replacing x by x minus 4. And then when we multiply out the brackets, we get 2x minus 8, which is what we want. So one approach you can take to these questions, at least in the early stages, is try what you think the transformation is, and then write out the result and see if it's what you expected. And if it's not, you can make a correction. However, over time, you'll probably find you can skip that step because you'll start to notice that that is going to happen and you'll adjust it beforehand. So in this case, you might spot in advance that whatever you replace the x with is going to be multiplied by 2. And then you can adjust your transformation accordingly before you actually apply it. Okay, now you've seen a couple of examples, I've got a few questions for you to have a go at. For each question, first of all, I'd like you to decide, does the order you apply the transformations affect the result? If it doesn't, simply write down a single sequence of transformations that would get from f of x to the result. For the questions where the order does matter, I'd like you to try and write down 2 different sets of transformations that will get you from f of x to the result. The answers to these questions can be found on the course page.